are looking at 4.1 where they ask us to draw a free body diagram for each of the boxes. So first of all, for the 5 kg, now on the 5 kg, it's on the 5 kg that the 45 newtons force acts. So that's our first force that we will draw in and represent is our 45 Newton force that is acting on the 5 kg. Now, what will the 5 kg experience otherwise? It will experience a force from the 10 kg on itself. So that would be our other force that we would represent is the force of the 10 kg on the 5 kg. And this one, we can let's just say it's the force of the 10 kg. Okay. So then it would always also have a normal force that it experiences as well as a gravitational force. So those are the other two forces that we have to represent on this diagram. So we will have the force of gravity, which is the gravitational force of weight, and the normal force acting up. On the 10 kg, now guys, there's something I missed because they said the coefficient of kinetic friction is 0.2. Okay, so in other words, we've got a frictional force that I haven't represented yet, so I need to represent that, and the frictional force will be in the opposite direction than motion. So I'm just going to draw in another force there. So just want to represent both forces. So that's my frictional force that I've represented there as well. So this, I will just use the symbol FF. Okay, so the 10 kg, it will experience a force that it is pushing it to the right, which will be the force of the 5 kg on it. Okay, so there's that arrow. Then I've got the force of the 5 kg on this one. Then it will also experience a frictional force in the opposite direction. And it will experience a normal force and a weight. Okay, so I just want to draw all the forces. It's quite tedious drawing it with these lines, so just bear with me. I'll name them all just now. So that would be my normal force, this would be my weight, and this would be my frictional force. Okay, now they say calculate the acceleration of the boxes. Now I remind you that once again, we set up two sets of equations. So we will set up equations for the 5 kg, and we will set up equations for the 10 kgs. So if we start setting up our equations, so it will be, and I just want to correct my pen over here. I see it's quite bad. So the net force will be equal to the mass times acceleration, which in this case, it would be 45 newtons minus the frictional force. And I'm just going to name that force of the 10 kg F, which is equal to the mass times the acceleration. Now, to simplify this equation so that I have all my answers that I can calculate it now, they say the coefficient of kinetic friction is 0.2. So in this case, the friction will just be the coefficient of friction times the normal force, and the normal force in this problem is equal to the weight. So this then just becomes 0.2 times 5 times 9.8 minus this force F, which is the force of the 10 kgs, which I don't know the magnitude of, is 5a. So simplifying and writing this equation in terms of F, I will get that 45 minus 0.2 times 5 times 9.8 gives a value of 35.2, which would be positive, but seeing that I'm transferring it, it would become negative, but then I would divide by negative straight throughout. So simplifying this, it becomes 35.2 minus 5a is F, and that's my first equation. Setting up the same equation for the 10 kg block, and I just want to remind you, like I've said before, so the force of the 10 kg is equal to the force of the 5 kg in this problem. Okay, So it's the same magnitude force, and that's actually according to Newton's third law, which we will be doing later on. Okay, so once again, we work with Newton's second law to solve this problem, which says F net is equal to ma. In this case now, it's the force of the 5 kgs, which is F, minus the frictional force, which will be equal to the mass times the acceleration. So in this case, that F we can replace from this side with 35,2 minus 5a. The frictional force will now be, I just want to create some space over there for me to write down. It will now be yes, that's correct. It's going to be the coefficient of friction of 0.2 times the mass. Now it's 10 times 9.8, which is equal to 10a. So in other words, if we get all the a's on one side, this becomes 15a. And on this side, 35.2 minus 0.2 times 10 times 9.8 gives a value of 15.6. So our acceleration, 15.6 divided by 15, gives an acceleration of 1,04 meters per second square. And this would be to the right. Okay, so meters per second square. I just want to make sure you know it's per second square there. Okay, then calculate the force that the 10 kg box exerts on the 5 kg. Now, very easy. We can use any of the equations to solve it, but I'm just going to use the one that's already written in terms of A. So 35.2 minus 5 times 1,04, which gives then a force of 30 newtons. And it's now the force that the 10 kg box exerts on the 5 kg. The 10 kg on the 5 kg is 30 newtons to the left. Okay, so make sure to add the direction here. So this was question 4 of exercise 1.2.